Hi, I'm an old guy and I do maths, and this may well be our first look at logarithms. It may mean that it's your second look at them, as in you had a look at them at school or somewhere else and you didn't quite get them. Okay. Well, I think that the easy way into this is to regard logarithms as just another means of expressing a value or a function. Let's start with that idea. Okay, so if we take this exponential function, y equals a to the power of x, we can rewrite this in log form. So this thing here is our base. Whether it's a or whether it's 2 or 3 or 15 or whatever, this is our power, our index. And so when we rewrite this in log form, what we're looking to do is to express pretty much the same idea, but we just do it in a different way. So our base gets written like this. It's log in base a of a particular number. So y is equal to a to the x. Y is equal to a to the x. So log in base a of a particular number is x. Okay, so it's just a rearrangement, a rewriting. There is more to it than that, but that's a good place to start. So let's take a look at this. We're working in base 10 to start with. So our base is 10. The number that we're seeking to achieve is 100. And we're wondering what the power of 10 might be to get us to 100. That's how you look at this. So if you had that much information, so it was basically a question, you would be being asked what index of 10, what log of 10 will give you 100, and the answer is 2. Let's try 1,000. Again in base 10. So what power of 10, what log of 10 will give you 1,000? The answer is 3. 10 to the power of 3 equals 1,000. Okay, another base. Let's try it in another base. So 2 to the power of 4 is 16. We know that. We've got it written here. But take a look at how it's set out here in log form. The log in base 2 of 16 is 4. 2 to the power of 4 is 16. Let's try doing this on the fly, shall we? Log, our base is 2, of 32 is equal to 5. 2 to the power of 5 is equal to 32. Let's try a couple more. 3 to the power of 1 is 3. We know that. So let's get our log set up. So this is in base 3. Just as this was in base 2, this is in base 3. And we're looking for what power of 3 we need to make 1. And the answer is 1, which inadvertently sends us about 3 or 4 lessons ahead. And I'll mention it here. When these two numbers are the same, the value of this expression is 1. We'll come to that. Okay. Oh, the favorite, negative indices. Okay, so let's try this. Set it up. So the log is 2. And we're looking for how we get from a power of 2 to 1/8. And the answer is -3. 2 to the power of -3 is 1/8. I hope that's a soft enough start to this. Logarithms can be slippery. It really pays to keep practicing. They are very, very useful, though. You're going to find that you use them in other disciplines. I mean, this is not a physics or a chemistry channel, but I know, speaking to my students, that quite often we wind up doing physics or chemistry questions for them because they don't understand logarithms and they require logarithms to solve their problems. So logs really have their uses, both in physics and chemistry. I'll tip you off to this now. If you are trying to solve for an index, for a power, rather than a whole number or a pronumeral, if you're trying to solve for a power, you're likely to need logarithms, or be very good with a calculator. Okay, that's enough. Thanks very much for watching. This is not straightforward, but there is a pattern to it. Learn the pattern, get used to it, and I'll see you next time. Bye.